Hello and welcome. This is Martin Percher explaining the use of ABES geometry control software. In this installment we will finally bring together all the bits and pieces we have created in the previous video clips, and we will create a bridge object. Right click, insert bridge object, and I'm giving it a name again, getting started bridge. And there is a little typo here. As always, this creation process brings us to the empty input dialog for bridges, which we see in front of us here. This input dialog offers all the tools to place an open number of segment groups onto an axis. In our case, again, it's very simple. We will only place this one segment group in one particular point on the axis. We start by selecting our only axis that we have defined in this project so far. And then we will use this space here to compile a list of segment groups, in our case only one. Right click, append, we give each segment group a name, and let's call it cantilever 1, and we select the segment group that we want to associate with this particular group. And there is one thing left to do still, which is to establish the exact position of this segment group on the axis. We do so by filling out this table here. This column here is for selecting points on the axis. Right click, choose item, and we select the pier, a point that we defined previously in the course of inputting our axis, and we match this point with our connection point within the segment group, which we also defined when defining the segment group. The program now knows where to place our cantilever segment group onto the axis, and it can assemble the segments in the correct geometry and position along this axis, like I said before, pearls on a string. Over here to the right, we now also have a list of all the segments considered in this bridge object within this group that we've just placed, and we have a column here where the program has generated an automatic name for each of the segments. We can go with this name, but sometimes it's appropriate to change this name so it correlates with a naming system that's used later on in the casting yard. Here is the point to do that. Simply change the name for the segments here in this column if you wish to use alternative names. Also, we have a list down here that includes all the casting sequences the program has detected within this bridge segment group that we've just placed. There are 2 casting sequences in our segment group, and the program has also given each of the sequences an automatic name. Again, we could change that here in this place. One more thing to do. We have set the precamber to consider. We could ignore it by clicking here and setting it to ignore, and we would be finished with this bridge. But I would like to spend just a little bit of time to explain the precamber input, because that's something that's very often an important part of the model before it gets passed on to the casting yard. We have so far worked in the Construct tab of this bridge dialog, and we're now switching to the Precamber tab. Clicking on Sync after accepting the data creates this table here. And let me just pull out these columns here so we can see better. Each line of this table corresponds to one joint along our bridge. So we get the joint between this segment here and this segment here in this line. And for each joint we have columns to define precamber information. In most cases the precamber information is only of interest in the Z direction, in the vertical direction, but in some cases it's also important to input the precamber in horizontal, longitudinal and lateral direction. We have a choice to provide this information in any of these coordinate systems, and if we have lateral precamber information to input, this is probably the most logic choice. The local axis in plan, longitudinal X, lateral to the axis in Y, and perfectly vertical for Z. In our case, I think vertical precamber is sufficient. This is input data typically delivered by a consultant, and in our case I will simply make up the numbers as I go. I will start with a 0 precamber here at the cantilever, at the pier segment, and then increase as I go away from the pier segment. 25 and make that 32, and I will try and do that symmetrically on the other side. 14, 20, 25, 32, 20, 25, 32. So this is my imagined precamber that I've just input, and I've assumed here that I'm inputting millimeters, and I've got a factor up here, remembering that the units I have been using so far were meters. I want to scale this down to millimeters. If I accept this data, the precamber data is set to considered, and it will be passed on to the casting yard and considered during geometry control at the casting yard using geocon. As always, we can get a visualization by right-clicking and preparing the default diagram. And finally, we can actually have a look and a view of our bridge that we have set out at the very beginning to model. It's worth pausing for a short moment and considering a few of the properties of the model that we've just created. I'm zooming in, and I would like to point to this segment here, which is the pier segment. This is the base segment. The two sides are in parallel, both will be cast against bulkheads. The next segment here has quite a skew shape, and the reason being that the pier segment is in fact placed, I'm zooming in a bit more, the pier segment is placed in tangent to the axis, and this first matchcast segment has the purpose of bringing the segment centerline back to the axis. And also the program knows that if we cast this, there will be a bulkhead on this side, and the sides here and here will need to be perpendicular to this bulkhead. So therefore this geometry of this segment is set out to bring it back to the axis, the segment center line, and also to make sure this segment can be cast in a rectangular casting cell. And same goes for this segment here. Again, the bulkhead is on this side here. We have right angles on these sides here, and this side here will be match cast against this segment. And so the setup here is actually quite complex, even though we have a very simple example. Each segment is now already calculated and drawn up in a way that can be produced in a casting yard.